In class, there was a question, and the question was, how do I get a step surface much like what BIG has? Get the sketch out. So in case of paneling, we create grid points like this, for example. And then we're taking a pattern, and that pattern then sits in the grid cell like this. So that it deforms to the curve. So it's like following the surface of this geometry, right? But what if you want a stepped pattern that follows this curve? Then the logic is a little bit different in the sense that you're creating a pattern that is on a plane. And that plane, then the corner, or however you align it to this grid, is sitting like so. So instead of it connecting at all 4 points, it's sitting on a plane at each of these grid points. So it's then stepped. And that's how the logic of the BIG Serpentine Pavilion works. So we can use BIG's Serpentine Pavilion as an example. For starters, basics, let's do east wall again, and we want a rectangle, right? So the rectangle has to be a rectangle drawn on a plane. So we don't want it distorted. We want it to maintain the plane. And the plane that we want, go back to shaded view to see the coordinate system, is YZ. Double click YZ plane. So I want plane to plane, YZ geometry. And immediately once I connect the wire, you see that a plane has appeared on each of these. Now, I'm going to simply make it 20 by 20, which was the original size, right? It says Y cell size in the previous video. If you want it, now Z cell size goes to here. You can ignore these names or rename it so that you understand, it doesn't confuse you, that this is actually Y and that's actually Z. And so immediately you see that these squares drawn on a plane appear. Now, if we refer to our BIG Serpentine Pavilion image, it's actually the squares have a thickness. So let's put an offset curve just so we can understand how to do that. So we're going to offset the curve, and you immediately see that a thickness has appeared. You can choose to whatever distance you want. I'm not going to make it very thick. So one integer number, maybe I don't want an integer this time. I can do a decimal, right? So 1 to 10. So less than gives me a decimal. So 3 decimal places now. And I'm going to leave it at 1. It looks pretty good as 1, to be honest. And then I want to obviously extrude this, and we're going to use boundary surfaces again. I think it's better than capping it at the end. So I'm going to need 2 edges, the offset one and the original rectangle, right? So I want this one and I want this one. So there's two, but right now it's creating a surface on both. I want the in-between. So if I want the in-between, I have to then flatten it to get a single parameter. And I can show you that it's created that surface in between by changing the thickness of the material. I'm going to go back to 1 because I think otherwise it's just too thick. And now I can extrude as normal. So direction I want to extrude in is X direction. And then factor, a slider again, I'll do less than to get a decimal place. And then I can increase that as I see fit. So now I have a stepped surface. I believe our previous thickness was 40. Let's keep it at 40 for comparison. So let's say, okay. And I'm going to bake this geometry so you can see what's going on. I will group that as well. Drag over and group. I'm going to change the color. I'll name it stepped box. And then I'm going to extrude it, bake the extrusion. I will like it to go on extrusion, okay. And now I have this geometry. And I'll move it over for comparison. So that's imitating more closely to our BIG pavilion.